Hi, so today we'll be working through pages 21 and 22. We're just going to cycle through these two topics, Riemann stones, differential equations. Tomorrow's your quiz, okay, just two FRQs. Bring your calculator. I'm also going to attach the formula sheet on page 27, 28 to the back of your quiz. So you get to have that again for the quiz that you're taking tomorrow. For homework, I'm going to be checking the rest of the packet, but I'm going to check all that on Wednesday. Okay, because tomorrow I just want you guys to just focus on getting the quiz. When you come in, you guys take the quiz. Ideally, you can work through all the problems so that you can use that as review, but I won't be checking homework till Wednesday. Tomorrow I'll have a help session, 7:15. I may change that time, either 7:15 or 7:30. I'll send out a reminder. I'm going to go over the last two pages in your packet, the morning review. Okay, so one Riemann stones and one FRQ, one Riemann stones and one differential equation. Okay, any questions about tomorrow? Okay. Okay, page 21. Okay, watermelons are beginning to come in season, and warehouse is receiving the watermelon over time. The strictly increasing and twice differentiable function W models the total amount of watermelons in a warehouse with t is greater than or equal to 0 weeks. It is thought that W will satisfy the differential equation dW dt, where W is measured in number of watermelons and t is measured in weeks. At t equals 2 weeks, there are 10 watermelons in this warehouse. So part A, write an equation to the line tangent to the graph of W at t equals 2 weeks. Use your tangent line to approximate the amount of watermelons in the warehouse at t equals 3 weeks. So we've seen this process, right? Tangent line equation. So go ahead and gather your order pair. Your derivative will get you your slope, point slope form. I know we're used to using x's and y's for point slope form, but we have to make an adjustment here. T is now your independent variable. W is now your dependent variable. Once you get your tangent line equation, you use that to do your linear approximation, which is enter in 3 for your interior equation into T for your linear equation. Okay, try that. Try number 1, part A. See if you can work through those steps, and I'll go through the part A with you. Okay, order pair 210. Slope comes from your differential equation, so that's your dw dt. I use that notation, that vertical line with 210 to indicate that my derivative could take on more than one variable. So that 210 is to indicate if there's a need for t and w, then I'll insert 2 and 10 in for those appropriate variables. And in this case, looks like both variables are used in the derivative. So we'll plug in 2 for t, 10 in for w, and that gets you a slope value of 4. You got your order pair, you got your slope. Typically, we like to use y minus y1 equals m times x minus x1, which is still our tangent line, but we just make a slight adjustment, right? Instead of x, we'll use t. Instead of y, we'll use w. And then we solve for w. Once you solve for w, then you do that last step, linear approximation. Just insert 3 into your t of your linear equation, and that gives you an approximation. And here are the approximations in terms of watermelons. So we have approximately 14 watermelons at when t is 3 weeks. Okay, any questions for part A? Okay, part B. Okay, use d2w over dt2. What does that mean? Find the what? Second derivative, yeah. We have dw dt, that's the first derivative. We just have to go one derivative down to get to w over dt2. Determine whether, and then after we find it, we're going to determine whether our approximation for part A is overestimate or underestimate. And the in terms of the watermelons, number of watermelons in the warehouse at t equals 3 weeks. So this is where this is our starting point. We're trying to get from dw dt to d2w over dt2. Now look at how this is set up here. We want to find the derivative. What do we have to involve here? Okay, implicit, yes, but something else that I have to point out. Okay, there's two variables, right? There's two variables. We can't just rely on power rule for one term. These are two distinct terms. Product rule. And when you go to product rule, just recognize that the denominator tells you what the independent variable is. So here, the independent variable is time, kind of like related rates. So that means every variable is getting impacted by time. When you take the derivative of t, it'll just go away. 2t just becomes 2. But w's derivative would become what? Yeah, dw dt. So that notation is telling you, okay, you find the derivative of t. Technically, it's dt over dt, but we know that can just go away. It's only that w that has, I've got to keep track of that. Keep track of that portion. Okay, so let's go ahead and find the derivative of each portion. Okay, product rule is f prime g plus fg prime. F prime, 2t becomes just 2, yep. W minus 9 doesn't change. 2t doesn't change. And then when we get to g prime, what's w minus 9's derivative? Just what? Yeah, just 1 dw dt. You can leave that 1 out if you want, but the 9 goes away. So we have to keep track of, yeah, that time is going to impact that w, so dw dt. We want to evaluate the second derivative. So it feels a little cleaner once you have this. Let's replace dw dt in terms of the original variables, and that way we can insert every piece with 3 and 14. Okay, so we have the tangent line equation. We want to know whether the tangent is overestimate or underestimate. We're going to insert 314 in for all the values here, and we're going to get a number, right? And that number, the important thing is whether that number is what? Yeah, positive or negative. That's all we care about. If it's positive or negative. If it's positive, then we know our graph, second derivative, is going to be part of a concave up graph. Our tangent line is going to sit below the curve. Right? If it's a negative value, then we know we're dealing with a concave down graph, and any tangent line is going to sit above, and therefore overestimate. Okay, so you can replace all of your P and W values with 3 and 14. And use your calculator. It should get you all the way down to get all the way up to 190. And that number is really not that important. It's really the fact that, okay, as long as it's positive, that's what we really want to be able to explain. Okay, any question with part B? Okay, next part. Solving differential equations. So let's see if we can begin getting our fractions lined up so that we can cross multiply and then separate the variables. Okay, does anybody still need to look at part B? Good. Okay, I've forced a 1 below the second term here. So I can see that cross multiplying that I'm about to do. Oh, and I want to keep pointing out to you that if you're dealing with a differential equation, especially on the AP exam, the parentheses are there to help you. Okay, so if you see a parentheses there, don't expand. Okay, the parentheses are there to help you separate the variables. They want you to take that first step correctly. So they're never going to initially, they're never going to trick you with the rearranging and make it difficult for you to separate the variables. If you see parentheses, keep it. Okay, they want you to see that first step through. Okay, so cross multiply. Okay, so that's my cross multiplying effort. Right. We're not seeing X's and Y's, we're seeing T and W, but we know that we're hopefully seeing problems enough where we're comfortable recognizing time is our X, and then whatever the other variable is our Y. So we want T's on the right, W's on the left. What's the one thing that's out of place? Yeah, W minus 9. If you want to move that W, that parentheses is there to help remind you, okay, I got to bring everything inside the parentheses with it. We should have full separation now. I'm going to just write it in a way that hopefully it's easier to take our next step. Okay, left side in terms of W, everything on the right in terms of T. What do we have to go through on the left side here? A little bit of what? Yeah, use substitution. I mean, if you're comfortable with recognizing that this U value is not going to produce any derivative except 1, you can jump to 1 over U and natural log. You can skip a number of steps if you're comfortable, but if you want to go through the full U substitution, I'll go through those steps. And the right side is just using what? Just power rule. Okay, good. Okay, U value is W minus 9. Derivative is 1, so no leftover coefficient. We make our substitution and everything comes out clean, 1 over U du. We recognize that as just a natural log rule. And replace the U back in terms of W. And you have the left side taken care of in terms of the calculus portion. Okay, right side, 2t, we use power rule. 2t becomes 2t squared over 2, and then don't forget plus c. Okay, calculus is done. And now we have 2 more things left to do. We have to solve for W, and we have to solve for C. Solving for C is one of those things where, depending on the problem, I want to solve for it. Just personally, I want to solve for it where I feel like is easier algebraically. So here, I'll prefer to solve for C a little bit later because I feel like I can get rid of the natural log before I get it a little bit cleaned up before I insert ordered pairs to solve for C. So that's what I'm going to do. Now, if you solve for C at another point, that's perfectly fine. Just know that our C values may look a little different initially, but in the end, we should match up. Okay, I'm going to reset, get that left side, get that right side cleaned up a little bit. Okay. And what can I do to get rid of that, to clean this left side up? Get that natural log to be moved. Yeah, raise both sides. E is the base. Left side cleans up. Right side, we can split up, bring that C down. Remember, you got to change your operations, right? If you split this up, this plus is going to change to multiplication. Right? Always watch out for that. Sign is not going to be the same once you go through that exponent property. Okay. E to the t squared plus c becomes e to the t squared times e to the c. And we know that e to the c is just one large c. Pull the c out in front, drop the absolute value. And now I can solve for C a lot easier. I feel like it's a little bit cleaner here to solve for C without dealing with the natural log. So insert my order pair 2, 10. 2 in for T, 10 in for W. Ten minus 9 is 1. 2 squared is 4. I'm going to solve for c. Divide both sides by e to the 4th. I get 1 over e to the 4th. Once I have my c value, reinsert into my equation, and I'm almost there. I'm almost there, able to solve for w. Okay, move the 9 over, get that w by itself, and this is perfectly fine. Okay, any questions here? Yes. Good. Yeah, that I do want to talk about that. I think this is where most students would stop, which is perfectly fine. But I do want to point out that we could clean this up a little further. Okay, we can bring that e to the 4th up to the numerator as e to the -4. And then we can further clean this up by merging the exponents together, t squared minus 4. Okay, so either variation is fine. If you leave it in this form, this is fine. Now, I do want to point this specific answer out, not because you'd have to write it on the test, on if it's FRQ, but this is probably how answers will be presented if it's a multiple choice question. Okay, so if you see this problem on the multiple choice section, and you get to this answer, that's fine, but you have to be able to select the correct answer choice. And you have to know that sometimes your form may be correct, but if it doesn't match this correct answer choice, I don't want you to get lost, feeling like, oh, I have the answer, but it doesn't look like my answer. Maybe I'm wrong, but maybe you are sitting at the right answer, just in a different form. So recognize the need or the potential for writing your answer in different ways to help you on multiple choice section if you come across a situation where your answer doesn't quite match the answer choice, and you have to find that connection between them. Okay, good question though. Part G. Right. Part G is easy. We just it says for the particular solution, evaluate W of 0 and explain the meaning of W of 0. We know W represents the number of watermelons at a specific week. So I can insert 0 in for T. It's going to give me a decimal value, but we're going to just round to the nearest whole number. W of 0 is closest to 9. So we say that must mean at 0 weeks, we have approximately 9 watermelons in the warehouse. All right, page 22, Riemann sums. All right, 22, the function f has a derivative f prime. F prime is increasing, and we know our f prime is always rising, and twice differentiable, so smooth curve all the way through, no sharp turns, no vertical asymptotes, no holes. Selected values of f prime are given in the table. It is known that f of 0 equals 3. Okay, for part A, for f prime, the conditions for mean value theorem are met on the closed interval from 0 to 3, so they're telling us that mean value theorem applies. The conclusion of mean value theorem over the interval from 0 to 3 for f prime is satisfied at c equals 1. So they're telling us that if we go through mean value theorem, we can guarantee whatever slope we're looking for, and it's going to occur exactly at 1. So let's just go through mean value theorem, right? Mean value theorem. We can adapt it, shift everything one derivative down. Normally it's normally it's f prime is f of x, f prime is f of b minus f of a or b minus a, but we're just going to shift everything down one derivative. Let mean value theorem be this being f double prime and find the slope of f prime. So whatever the slope is between the endpoints on my f prime graph, that slope is going to live somewhere on the curve. And we know that slope is going to live exactly at 1. So we know where, so we just figure out, we know A and B are 0 and 3, right? They're giving you the endpoints. So basically just find the slope between the order pairs of 0 and 3. Four minus -1 is 5, 5/3. And we can guarantee that there's a slope of 5/3, and they're telling us to satisfy the c equals 1, so we know at 1. There's going to be a second derivative value of 5/3. Okay, part B, Riemann sum. Now, you know your graph is always increasing, right? So if your graph is increasing, you should be able to sketch a right Riemann sum, rectangles, and convince yourself whether it's going to be an under or over approximation. So if you were to plot these order pairs here, maybe the graph looks like this. Rising, but then you want every rectangle to be determined by the height of the right endpoint. So you see that you have portions of the rectangles that obviously is sitting above the curve. So you know that these rectangles are going to overestimate the actual area under the curve. Graph was decreasing, then the right Riemann sum is going to end up under approximating. And these are not anything you want to have to memorize, right? You just be able to sketch the graph and attach and then create your rectangles and visualize whether your rectangle is sitting below or above the curve. If it's below, you know it's going to underestimate the actual value. If you see the rectangle above the curve, then it's going to end up doing a job of over approximating. F prime is strictly increasing. A Riemann sum will end up over approximating the area. Okay, part C. Evaluate the definite integral from 2 to 3 of f double prime of 2x minus 1. Show the work that leads to your answer. Okay, we got to take the antiderivative, but before we do that, what process should we make ourselves go through? Yeah, use substitution. Let's get that 2x minus 1 figured out. We know that there's probably going to be a leftover coefficient. We want to keep track of it, so use substitution is going to help us do that for us. Okay, your u value will be that what you see inside the set of parentheses. Okay, what's our leftover coefficient that we need to keep track of here? There's going to be a what? 1/2, yep. Push that 1/2 out in front. Okay, apply first theorem. You know f double prime is going to rise up to f prime. Okay, we can work in the bounds, but not quite yet, right? This is in terms of u, your bounds are in terms of x. Typically, I think we prefer just to bring, either you can have your bounds in terms of u as well, but I think we prefer just, most of us prefer just to have everything in terms of x. Let's bring the original variables back. Now we can work the bounds in 2 and 3. Okay, upper bound first. Minus lower bound. I get f prime of 5 minus f prime of 3. Keep track of that 1/2. And then we have table of values that we can pull from, right? F prime of 5 is 7. F prime of 3 is 4. 7/2 minus 4/2 is 3/2. Okay, questions? Okay, we have another solving differential equations, so let's practice through that. Go ahead and set things up. So you can separate the variables, cross multiply. After cross multiplying, you may still need to do something to get the variables to completely separate. So once I cross multiply, I see the dy dx's nicely in their right spots, but there's still something out of place, and what else needs to be moved? 3 minus 2y, good. So we know the y's come over, but you got to bring everything inside the parentheses along with it. So 3 minus 2y on the left. All right. What do you see we have to go through on the left side? Good. U substitution. Most likely it'd be looks like it's gonna be a good one for natural log, but U substitution, because that 3 minus 2y is going to produce a coefficient that has to be part of our answer. So the right side is just f double prime becomes f prime, right? So natural log on the left, and right side is just applying first theorem. Okay, 3 minus 2y produces -2. Solve for dy, we get du over -2. Make our substitution. Looks like it's going to be a -1/2 that needs to come out in front. Okay, natural log on the left. First theorem on the right. One over u becomes natural log of absolute value of u. Bring the u back in terms of y. The right side, f prime of x plus c. Now, up to this point, you've earned the majority of the points. Okay. The only thing left to do, you've done all the calculus, you separate the variables, plus c shows up. Majority of the points are there. The only thing left to do is to solve for c and to solve for y. Okay. Now, I do want to point something out here. On the AP exam, you may get a little bit of tunnel vision where you're like, all right, I want to just get this all the way figured out. And this is where you're going to have to make a decision. I would say try your best. Sometimes to get from here to the end is almost not worth the trouble, in the sense that all this is only worth 1 point after this, right? And if you're spending 10 minutes on this portion, when there are other FRQs that you can be working on, it's not worth the effort, right? You want to you try your best, but you know that this is only 1 point from here on out. And yeah, if you want to kind of give that, just want to reassure you that, okay, if you get to this point, you've done really well, right? And that last point, if you have time at the end, come back to it, try a little bit of it. If after 3 minutes you're still stuck, come back to it after you've taken care of the rest of the test. So you want to kind of understand the point distribution for these problems and work accordingly. Okay, but we're going to try and see if we can go through the rest of this problem, but just to kind of show you that it can get a little messy with the process moving forward. It's still worth it for us to go through to kind of practice, the algebraic steps here. Okay, but next thing, right, I want to solve for y, prefer to solve for y before the c because there's a natural log involved. So I'm going to multiply everything through by, I want to erase everything with e as the base, but there's something in the way that's preventing me from doing that right now. What needs to be moved before I can get that e and natural log to cancel out? Yeah, so what can I do with that negative 1/2? Yeah, multiply everything through by -2. That will force that negative 1/2 to go to the right side. And then I can involve base e. Okay, base e raised to the exponents. We know e and natural log goes away. The right side. Notice that when I distribute the -2 through, it goes with the f prime, but it doesn't appear for the c. The c will just take in that -2 without to put a -2c. Go ahead and separate that right side. Drop the absolute value. And I feel like at this point, this is where I would go ahead and solve for c. You can see how things can get a little messy here. Even after I solve for c, I still got to solve for y. And when I solve for y, I got to deal with fractions. But all this effort is just to get that final 1 point. Okay, let me just show the key here. If I solve for c, it ends up being 1 over e squared. Once I solve for c, I plug it back in. I solve for y. Once I solve for y, the direction says use your solution to approximate or to find y of 2. So my final order of business is to plug in 2 and for x, to get it down to a number. Okay, so tomorrow I'm not going to check any homework, but I'll have a morning help session, 7:15 or 7:30. I need to figure out what time. Probably 7:15. But I'll send out a reminder this afternoon, and encourage you guys to work through the rest of the worksheets for practice. But I'll check the remaining pages on Wednesday.
Thank you.
Thank you.
Thank you, Mr. Ling. Have a good day.
Have a great day. See you tomorrow.
Thank you.
Thank you. Thank you. Thank you.